This is Math 172 review for the final exam, along with the answer key. I'm going through with each example. Number 1, indicate which of the following four graphs is the correct graph of this function. So if we just let our x equal 1, we get 9/4 and negative 1, which is f of 1 equals 4/9. Well, 4/9 is the same as 0.4 repeating, and 1.4, that doesn't have 1.4. The second one doesn't. This one looks like it might have 1.4. That's not even there. That's not close. Now let's try another one, f of 0. Anything to 0 power is 1. So 9/4 to the negative 0, or just 0 power, is also 1. So that's just going to be f of 0 is equal to 1. So that's 0, 1. So this is the only graph that satisfies our function. For number 2, we want to solve the following elementary exponential equation. So we have 2 to the negative x is equal to 8. And we know 8 is 2 times 2 times 2, which is 2 to the third. So we just take our negative x is equal to 3 and set those equal to each other. Well, negative x is like negative 1x. So if we divide by negative 1 on either side, we get x is equal to negative 3 for number 2. Let's take a look at number 3. A certain species of deer is to be introduced into a forest, and wildlife experts estimate the population will grow to p of t is equal to 719, 3 to the t over 4, where t represents the number of years from the time of introduction. Step 1, what is the tripling time for this population of deer? Well, first we got to figure out what it is tripled. So our original amount is this 719. We multiply that by 3, and we get 2157. So we're going to set that equal to our function. Then we're going to let that be our p of t, 719 times 3 to the t over 4. If we divide both sides by 719, we're going to get that 3 back, because that's how we got the 2157. So 3 is equal to 3 to the t over 4. Well, there's a little 1 here, so we have to figure out what our t is. So if 1 is equal to t divided by 4, we're going to have to multiply by 4 on both sides, and our t is equal to 4. So the tripling time for this population of deer is 4 years. Okay, so for the second part, how long will it take for the population to reach 19,413 deer? So we need to, let's add another slide. Take our 19413 and set it equal to our function, which was 719 times 3 to the t over 4. So the first thing we're going to do to solve for t is divide both sides by the 719. And we get 3 to the t over 4 is equal to 27. So let's rewrite this 27 as a power of 3. We know 3 times 3 is 9, and times the number 3 will give us the 27. So 3 to the third is equal to 27. So 3 to the third equals 3t over 4. So we're going to take our 3 is equal to t over 4 divided by 4, and again we're going to multiply both sides by that 4, and we end up with t is equal to 12. Okay, so that's going to be, how long will it take? 12 years. For example number 4, Bobby is working in a lab testing bacteria populations. After starting out with a population of 266 bacteria, he observes the change in population and notices that population quadruples every 22 minutes. Step 1. Find the equation for the population p in terms of time t in minutes. Round values to 3 decimals. Alright, so first we're going to start out with our finding out what we've got here. Well, we know it's going to be 266 n to the 22 is equal to, we have to figure out where this value is going to be. So we have to start with our quadruples. It quadruples every 22 minutes. So we have to take our 266. That does not look much like a 6, does it? 266 times 4. We multiply 266 times 4, and we're going to get 1,000 60. 6 times 4 is 36. 66. I think I got that wrong. Let me pause this for a moment. 64. Okay. So I couldn't read my own handwriting. So we set it up like this. So 266 n to the 22 equals 1064. We're going to solve for hen here. That's going to be part of our equation. So we divide by the 266. We get n to the 22 is equal to 1064 divided by 266 is going to give us that 4. Okay, so we're going to give a decimal rounded to 3 decimal places here. So to find out what n is, we're going to do the 22nd root of this side and the 22nd root of 4. So when you do the 22nd root of 4, you just type the 22 second caret 4. And rounded to 3 decimal places, I get n is equal to 1.065. So our answer for the first part is going to be P of t is equal to 266 times 1.065 raised to the 22nd. Well, that's going to be our t actually. Raised to the t. That's the time. And that's in minutes. Time is in minutes here. All right, find the population after 2 hours. Well, this is in minutes. Time is in minutes. So 2 hours is 2 times 60, which is 120 minutes. So we're going to substitute 120 in place of our t. So we're doing the p of 120 minutes, which gives us 266 times 1.065 raised to the 120. So we do in our calculator very carefully. We're going to round to the nearest whole number. We get 509136. I get 0.8, so I'm going to round that up to 509137. So we get 509,137 bacteria in 2 hours. For example number 5, I want to indicate which of the following 4 graphs is the correct graph for this function. Q of x equals log base 6 of x plus 3. Well, that plus 3 tells us we're going to go up. All this does is tell us we're going to go up 3 vertically. So which one of these goes up 3 vertically? Well, that goes to the right 3. That goes down 3. That's flip-flopped, and there's no negative there. So the only one that goes up 3 vertically is going to be this guy right here. Example number 6. Evaluate the following logarithmic expression without the use of a calculator. Write your answer as a fraction in lowest terms. So to rewrite this, we take our 81 is equal to 1/3 raised to the x power, because we don't know what that is. We're going to rewrite 81 as a power of 3. 81 is 9 times 9, which is 4 3s. 3 times 3 times 3 times 3. All right, so that's going to be 3 to the 4th power is equal to 1/3 to the x. Okay, so we can flip-flop this. This is not going to be too difficult. Let's rewrite this 3 as 1/3. 1/3 means our power is going to be -4. So our x here is going to be equal to -4. So my fraction or reduced lowest terms, it's just -4. The answer is just -4 here. For number 7, use the properties of logarithms to expand the following expression as much as possible. Simplify any numerical expression that can be evaluated without a calculator. We have, this is really small, I'm going to rewrite it, ln of 9x squared over y to the 7th. So we're going to be using the logarithmic property of division, which means we can subtract. So divide means to subtract. Divide means minus. So we can rewrite this as the ln of 9x squared minus the ln of y to the 7th. Okay, but we also have a product over here. And multiply means you're going to be adding. So we're going to do ln of 9 plus ln of x squared minus ln of y to the 7th. Okay, now we have to use our power rule because we have to simplify this all the way as much as possible. And so to do that, we know that if we have a power, these powers up here, right up here, these guys, they get to go in front for multiplication. So we're going to rewrite this as natural log of 9 plus 2 times the natural log of x minus 7 times the natural log of y. So that is as simplified as we can get it. Put those little times in there so you can see that those are just ln natural logs. All right, and that's for number 7. Let's take a look at number 8. For number 8, we have 3 times log base 8 of x over 3 minus 5 times log base 8 of 1 over y. So here we want to subtraction, we're going to change to division. So we're going to rewrite this as 3 over 5. We've got log base 8 of x over 3, and then over log base 8 of, because they have the same base, 1 over y. We're going to take these guys right here, and we're going to make those into exponents instead. So the 3 is going to be up here, and the 5 is going to be up here. So we have this to become log base 8 of x over 3 to the 3rd divided by 1 over y to the 3rd. And when we divide, we multiply by the reciprocal. So we have log base 8 of x to the 3rd, and then 3 to the 3rd is 27, times 1 to the 3rd is 1, and we have y to the 3rd because we're flipping that over 1, which gives us simply log base 8 of x to the 3rd. That is supposed to be a 7. Oh, it's supposed to be a 5. That is supposed to be a 5 there. Sorry about that. Let's fix that up. And 1 to the 5 is a 5. So it's y to the x to the 3rd, y to the 5th, all over 27. And that's our simplified log. For number 9, solve the following exponential equation. Express your answer as both an exact expression and decimal approximation rounded to 2 decimal places. So we're going to have 2 answers here. We're going to have the exact and we're going to have the decimal. So to find the exact, we're just going to natural log both sides first. We're going to natural log of e to the 2x plus 3 equals natural log of 7 to the 5x over 3. And this simplifies, these get rid, the natural log and the e get rid of each other. So we get 2x plus 3 is equal to, and then with the natural log we can bring this guy out front. So we get 5x over 3 times the natural log of 7. And then we're going to clear that fraction by multiplying both sides by 3. Over here it cancels out, so we just get 5x times the natural log of 7. On the left-hand side we're going to distribute that 3 in. So we get 6x plus 9 is equal to 5x times the natural log of 7. So what we want to do now is we want to get the variables on the left and the constants on the right. So I'm going to subtract the 5x times ln of 7 and subtract the 9 from each side. So we get 6x minus 5x natural log of 7 equals negative 9. So now we have to factor out our x. So when we do that, next slide please. Oop, I gotta add one. Insert a page. So when we do that, we get our x times 6 minus 5 times the natural log of 7 is equal to negative 9. And then we divide both sides by 6 minus 5 times the natural log of 7 on both sides. and this is the answer until we stick it in a calculator. So the first part of your answer is going to be -9 divided by 6 minus 5 times the natural log of 7. When we stick that in our calculator, we end up with 2 decimal places, 2.41 to the nearest 2 decimal places. For example number 10, we have log base 3 of x minus 3 plus log base 3 of x plus 1 equals log base 3 of x plus 2. We're asked to solve the following logarithmic equation. Express your answer as either an exact expression or a decimal approximation rounded to 4 decimal places. If there is no solution, say no solution. But there is a solution for this one. So we're going to take our log base 3. We're going to take these two and we can just FOIL those together. We get x minus 3 times x plus 1. Log base 3 of x plus 2. And so when we FOIL that, the logs just kind of disappear for now. And we end up with the x squared minus 2x minus 3 is equal to x plus 2. We subtract the x and the 2 from the right-hand side. And we end up with x squared minus 3x minus 5 is equal to 0. So this one, I'm going to throw it in the quadratic formula. And at the end, we're going to check it, because not everything works. You can't get a negative inside of your log here. So if you get a negative value, that's going to make this negative. So the negative number is not going to work. So we have a is equal to 1, b is -3, and c is -5 in the quadratic formula. So we have x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Which is going to be x is equal to negative plus 3, because b was a -3, plus or minus the square root of b squared, which was -3 squared, which is 9, minus 4 times a, which is 1, c, -5, all over 2 times a, which is just going to be 2. 2 times 1. That gives us 3 plus or minus the square root of 9 minus a -20, which gives us plus 20 over 2. So we have 3 plus or minus the square root of 29 over 2. So we do the square root of 29. I just did it all in the calculator at one time. 3 plus the square root of 29 divided by 2. If you're going to use the parentheses all at one time, press enter, then divide by 2, or use parentheses around the numerator and then divide by 2. When I did a plus to 4 decimal places, I got 4.1926. When I did minus to 4 decimal places, I ended up with -1.1926. Remember, we said we couldn't have a negative value. Therefore, the solution for this one is 4.1926, because you can't have negative logs.